Hey guys, welcome back to the latest episode in the Torana Resurrection Build Series. I'm going to do something a little bit differently today. I'm going to actually show you what you're going to see at the end of the episode right now as a bit of a teaser. So, we're going to be creating this fully 3D printed custom rear Torana flare with the help of some 3D scanning, my 3D printer, and this other Torana of mine. We've also got some old parts from the crashed car. And yeah, by the end of it, you're going to see how this looks on a Torana. So this video is going to be a little bit different to what we've done already. There's going to be lots into it. It's probably the biggest episode that we've ever done. So bear with us. Hopefully you enjoy it. Give us some feedback in the comments. Make sure you're subscribed to the channel. Please hit like. It really helps with the algorithm. And overall, I really hope you enjoy this episode because I've had an absolute ball making it. So let's get to me from a few days ago when we started the project, and yeah, enjoy the episode. Thanks again. So today we're in my shed again. We are stepping away from the repairs side of the car, and I'm gonna go into a little bit more detail on some 3D scanning, some custom 3D designed parts, and showing you a little bit of my process behind it all to show you that side of the build. So this isn't my crashed Torana. This is another car that I've had. It's a factory SS hatchback. I've had this for about 15 years now. I've picked it up. It was a one-day project that I keep delaying and putting off. About 12 months ago, I made a start on repairing it, and yeah, it's kind of been pushed to the side again. So maybe I might start repairing this soon. We might even make some videos of it. If people are interested in the content, maybe I will start stripping this down, and this will be more of a DIY type project. So maybe I might get some tips and advice off Dale. In the last video, he said he was going to show some good DIY repair jobs. So maybe I could put some of them to use on this car. It's actually pretty, I'll show, if people are interested, drop a link in the comments and I'll do a walk around of this car and show people what it is. But the reason I've got it here is because I want to do some 3D scanning of panels, so then we can take the next step and start designing my custom flares on a real world model. So the models that you might have seen in my renders, they're created off real world dimensions, but they're created from reference photos. So visually they look right, but they're more like, think of like a video game model. So they haven't been created using scan data. They've used blueprints and photo references to create a realistic looking 3D model. It's much cheaper to create a 3D model that way, so then we can keep the prices down for the actual projects. Otherwise, if we had to 3D scan every car that we do renders of, it would be a logistical nightmare trying to actually scan cars, because so many of you guys come to me with jobs and we've got to mix and match parts from multiple cars to actually create the final thing. So if we can create our 3D models from photos, it's much easier and cheaper to create the renders that you would have seen on my page. The renders that I've already done of my car, I've just created those flares on my base model. So now what I need to do is scan a car, translate those models onto a real world scaled proportioned panel, which then we can print on the 3D printer and create an actual part that will fit perfectly on the car. My plan today is I'm going to show you how I 3D scan a panel. It's all kind of new to me, to be perfectly honest. Most of it I've just been doing visualization jobs, but I really want to step into this realm of 3D scanning and creating custom parts because one, it's really fun, and I think that's really where the future's going. The last few years when I've been to SEMA, there's so many custom 3D printed parts and integrated things all around these builds, and it's the way of the future. So on my own project, that's what I'm using all these tools for, and hopefully we can create something really cool, and then hopefully I can help do it on projects of you guys out there. First things first, let's talk about my 3D scanner. So this is an Einstar Vega. It's relatively new to the market. There's another handheld scanner that Einstar do, I think it's just called the Einstar. They're relatively affordable. High level scanners still cost $20,000, $30,000 and they're exceptional. But something like this, from memory, this is about 2,000 Australian dollars. It's almost a pretty cost effective tool to have in the workshop. And hopefully, as you'll see over the course of this video, that what it allows you to do and create, it'll only just blow your mind of what potential and what possibilities are out there. The reason I chose this one is it does everything on the unit. So a lot of other 3D scanners you have to have connected to a laptop or something. So this one does it, we'll get into it in a minute, but this one does it all, it processes it all on the unit. So I can just scan the panel, it comes up on the back of the screen here, and then I can process the point cloud and create the model all on the unit, which is really handy. So you don't have to walk around with a laptop always tethered to you. And also you need a really strong laptop to process the data that these things spit out. So having it all on board here is super handy for these quick little jobs where I can get a call out and go scan someone's car and then create a part. These are little scanning dots. So this helps the tracking. So we'll go into it when we start doing it. On a big blank panel like this, the scanner, seeing it's only scanning a tiny little section at a time, when you're going over an area like this, it actually forgets, it doesn't realize what it's looking at, so it can kind of stuff up the model. So you stick these on all around the panel, and the scanner then connects them all up and works out exactly what it's looking at. This is a little calibration pad, so we'll go into it because I haven't used, about every week it tells you to recalibrate it just so it makes sure it's picking up all the sensors and everything correctly. So I'll run through that with you on screen just to show you how it works. But that's a little calibration pad and then the box it comes in. This is a scanning spray. So this you can spray onto the panel. So scanners also don't like reflective surfaces. That needs to see something, or glass as well. Sometimes it just looks straight through the glass. So you can use this. This is like a special 3D scanning spray. You can spray it on the panel and it kind of creates a dusted, powdered look over the panel that you can then scan. And then this stuff just disintegrates away, it vanishes away is what they call it. So you spray it on, it stays on there for an hour or so, and then you come back and it's completely gone, no residue. It's like magic spray. It's actually really cool. I'm not sure if I'll need that on these panels or if the dots will work well enough. But hey, we'll do a bit of trial and error, see what happens, and I'm kind of learning this tool at the same time as you guys. So bear with me, and if there's professionals out there watching me doing this and I'm doing something wrong, leave a note, be helpful, and yeah, we'll see what we can come up with. What I want to do is, you might see I've got my old flares here behind me. So I know I was saying in previous videos that I wanted to go back down once Dale had the rear quarter welded on, but what I thought might actually work better is, because this car's already complete, every hatchback Torana should be the same, should be touch wood. It probably isn't, but we can always tweak things if we need to. All right, so I'm gonna do 2 scans today. I'm gonna start by scanning the base panels, the standard flareless Torana base panels, because I actually want to get all this data from the wheel arch, because I don't know how many people know this. I've got the old flares here from my crashed car. The left-hand side of the car flares were still fine. The right-hand side, particularly the left-hand side, particularly the left rear, was kind of obliterated. Going back to what I was saying, so this shape through here is actually the profile of the flare here. So many flares over time might not look right because they've actually, like, the fiberglass is kind of like squeezed in. So if you look around at Toranas at car shows, some flares fit pretty well, others fit absolutely horrendously. When I first installed these on my car previously, I didn't realize that how the shape needed to go. So I kind of just bolted them in place, went, yeah, that looks good, made sure they were the same heights left and right, and attached them. I should have spent a little bit of time and re-gapped the flares and made them spot on, but hey, it was young Matt. I think when I put the last flares on, I was probably 20, 21 and didn't know what I was doing. So I'll scan this base. So I really want to pick up this key detail around here because I'm going to use that to create my flare. Then I'm going to put this flare onto this panel. I'll just attach it with some double-sided tape or something to just make sure it's roughly in place. And then we'll scan it again because I want to get all the profiles of the factory Torana flare. Because personally, I think the shapes, the side shapes like this of a Torana flare, the general sizing and everything of the flare on a Torana is pretty much bang on. Like when done right, flares on a Torana are spot on. All I'm trying to do with the custom flares on my car is slightly tweak them. I want to keep the same angles and shapes because I think proportionally that works really nicely with the original shape of the Torana. I'm not trying to create something drastically wildly different. But my personal opinion, some of those bigger, wider flares that people put on the Toranas, I feel like they just look a little bit out of proportion. They look a bit bulbous. That's just my opinion. Other people probably think something differently. But my opinion is they don't quite look right because they look like they've stretched them out and they just look a little bit odd. So what I'm planning to do, and hey, whatever I come up with, some of you guys out there might think they look stupid as well, but I'm doing it to what I feel looks right. So by having the two different scans, we'll have the standard panel and then the flare on the panel. I'll then use both of those to create my custom design flare. So we're gonna do the front and the rear quarter. The other good thing about using this car is I've still got the original flareless section in place, whereas on my hatch, I've hacked out all this already. And on the left-hand side, the same thing, I've hacked out all the inner. So I thought by using this car, I can actually get all that information. My wife's got a UC Torana hatchback, and it's slightly different through here. I might also get a scan of that. I just want to overlay the UC front guard, particularly this lower section here where I want to do something a little bit unique with the front spoiler. I might not use it, but I might just get the data to just see how it compares and how the roll-in works and where it sits. So by having it, I've got it and I can use it and just see what happens. So maybe I can start by giving you a quick run through of the 3D scanner. I'll show you how to calibrate it all. And I guess we can then get stuck into scanning some panels and creating some 3D models. We'll start by recalibrating it. So I'll just run through what it is asking me to do. So it says step 1. Start with the back side of the board. Okay, so this is all ready to go now. So what we'll do, I'll clear a bit of space and we'll scan this front guard. All right, now, because I'm lazy, but also lucky, I've got a hoist. So to make life a little bit easier for me, I'm gonna lift this up so it's all at a nice, easy working height. That's better. So I thought I might show you first when you try and scan without any dots on it to just show how tracking can get a little bit lost. So what I'm gonna do, I'll try and show you. I'm gonna go in fast mode. Now I can't remember off the top of my head what the tolerance does, what the scan resolution is. It might tell me here. If it's not, I'll put it along the bottom here. So what HD mode is, high definition mode, and what fast mode is. Both are still extremely accurate. HD is more for if I'm scanning like an engine part or something that I want really, really tight detail. For this, if I'm getting in within, I might even be able to look it up here. There we go. The resolution on fast mode is 1 to 2.5 millimeters. So I'll go to the highest spec on that, so within 1 millimeter. For what I'm trying to do with these flares, that's absolutely perfect. There's a few other features that we can do here. We can acquire the texture, so if it had color and stuff, what we're doing, not important. Let's start and see what we can pick up. It might scan all right. So you just move it in and out, and it's got a little bar here that tells you when you're close enough. 1, 2, and there we go. I need to go back a bit further. Let's see if it can pick anything up. Yeah, you can see it's struggling to get. It's just struggling to get enough detail. So you can just see it just keeps getting lost. So I'll stop that. I'll put some marker dots on and we'll see if we can have a bit better luck. These are 12 mil marker dots, which the Einstar, when I first got it, it only supported, I think, up to 6 or 8 mil, but then they've they added a firmware update that now they support these 12 mil ones, which makes it easier on this wider, bigger scale stuff. So if we just stick some of these randomly around, there's probably an art to it. I don't know what it is. As long as they pick them all up in the field of view that you're going for, and you don't kind of like lose any, that should be enough. Stick these on. I know I've seen some people have they make these magnetic so you can just reuse them. I picked these up off Amazon and they weren't that expensive, but they'll be annoying to unstick. And now I only really need the data around here, because that's where the flare's gonna go, but I might as well, I'll try and get all this detail up here as well, because it never hurts to have it. And we'll see, it's probably not enough, but let's see how we go now. Yeah, it's not losing tracking anywhere near as much now. It's picking it up pretty much first go. So if I just go nice and slow, I don't know if you guys can see the screen from where you are, but basically once you go over things, it goes green. And where it's red is basically saying we need some more. Sorry, talking and scanning is, so hold it there, it picks up exactly roughly where we were looking before. You see those little red dots on the screen is it's recognizing that they are tracking dots, which is helping it work everything out. And because I got those tracking dots out, I can actually scan a little bit on top as well, and it's keeping it knows what it's looking at, basically. So I'll pause it for the time being. See if I can show you on screen here. So as you can see, it's done a pretty good job. If I rotate it around, it's that's looking pretty good to me. So if I wanted to, I can pause and start again and go back and add more in, or I can just tick complete. And what I'll do, I'm actually going to process it on the computer. If I wanted to, I could process it and spit a 3D model out straight from here. But all I want to do is basically create this point cloud, which is, if you look, it's just tiny little dots. That's all the scanner is doing, is scanning tiny millions of little dots. I think, I don't know if you can read there, it's 169,000 points or little dots that it's picked up. So I think that's pretty good for this front guard without any flares on it. I could get some more information around there, but I think for what I need, that is pretty good. So now let's get the front flare on and we'll do a scan of that. All right, so I don't know if this is gonna work or not. I've just put some double-sided tape where the bolts usually go. I don't know if it's gonna be strong enough. It just needs to be strong enough for a little bit to stay on there, and then I might whack more tape on in a few other spots, but so there we go. It's kind of holding. If it falls off, it's not the worst thing that's happened to this flare before. It might be worth just chucking a few, I'll put some scanning dots on this as well, because it might probably need it. Get rid of some of the dust. I don't know if the vinyl wrap texture will help it or make it worse. So let's put a couple of dots on, watch it fall off. Let's hope this works, and let's start the next scan. So we'll follow the same process, probably just fast forward through this bit as you see me scanning it, and probably, and everyone out there, cross your fingers that it doesn't fall off. It's picked up some, not sure what some of that stuff is. I should be able to delete that in the post-processing. That's a bit of a misalignment, but I can tidy that up. That's okay. We'll go on the computer and do all that because it's much easier than doing it on the back here. But as you can see, that's pretty good. That's exactly what I want. I just wanted to get that profile of how the flare sits and kind of it kind of looks like, you know, from these angles. I'm just gonna use them as reference, that's all. That's all I need it for. So tick on that. Now we've got that, I'll just hit complete. Now I reckon we move on to the rear quarter and we'll get that data for there, and then we can jump on the computer and start mucking around in there. So move to the next position. Okay, so we're back here on the rear quarter now. So the rear quarter on this one is not exactly perfect. So I have to be a little bit mindful of that. It's got a bit of a dent here, and the one I need to just be careful of is this, there's like a dent just here. So I might cross-check a few other things. Again, I might take a scan of my wife's UC hatchback because this is identical in this area. So I might also do that just to compare it all. But also got to remember, the main thing I'm trying to do without the flares on is I want to get this shape through here, make sure that's right. And then of course the bit where the flares bolt on, which is going to be kind of just above this crease line, if you can see. So as long as that area is all pretty good, we should be okay. The other thing is the front guard, because I have it in a epoxy primer, it's got no gloss to it. So it's going to be interesting on this rear quarter because this is still shiny from the original paint. If I need to spray some of the scanning spray on there to help with tracking and picking things up. So just like before, we'll put some of these scanning dots on and we'll go from there. So I think I will put some scanning spray on this just before we go to scan it, because black sections are also notoriously bad. So the original paint job on this has black down here along the sills. And I noticed it when we were scanning on the front there. The front guard scanned really nicely, but as soon as it hit the black here, it just didn't even recognize it. So I think it'll help to just give it a dusting over the top, and we should be able to then collect all the data we need from this rear quarter. So let's get stuck into that. So this is the scanning spray, A-sub, it's the blue can. There's also a orange can, I think. One lasts longer on the panel than the other one, but they both disappear after a while. So apparently this one evaporates within 4 hours. It is dependent on temperature. I remember I mucked around with this in the middle of summer and it disappeared a lot faster than 4 hours. It was under an hour, it was pretty much gone. So it is mindful of temperature as well. But we're in the middle of winter here in Melbourne, so it should stay on for close to the 4 hours like it says. I'll spray some of that on. And hopefully you can watch it kind of, yeah, you'll see what happens. It's about 50 bucks a can as well. So you don't want to use too much if you don't have to. So I don't know if you can pick it up in the on screen, but it kind of makes it go white. I might not have put enough on there, but I mainly wanted to get it on these black areas down here. So hey, we'll see how it scans and we'll go from there. Okay, so see how that comes up. should be pretty good for what we need. Tick. And now I'll try and do that rear flare like I did the front flare. All right, so rear flare's ready to go. Just got some double-sided tape on there. Let's hope it works okay. It is a bit bubbly off this tiny little dent here. And then just the crappy shape of these Torana flares that have, who knows, I can't remember when I bought these. But hopefully that's enough. Hopefully it's enough to get the data I need and just the references of the shapes and stuff as I mentioned before. So let's get scanning before it falls on the floor and I lose my mind. Let's do it. I'll add a few more of these tracking dots. And then I'll give another spray. And then I noticed before, I need to just wipe it off these because these are kind of reflective. So. All right, let's get scanning again. So we'll take a look at that. It's pretty good. You can see it even picked up the inner wheel well there. Which could be very handy for working out wheel sizes. That's a future problem for this car. All right, we'll see out. I might just try and do a little bit more around this rear area here. I don't know if you can see it. It's there. There's a couple of red dots there. I'm not sure if it's seeing through from behind, but hey, I can do it. Okay, so I think we should be pretty good now. That is looking pretty good. So, take that one. And what we'll do now, I'll take this up to the computer and I'll transfer the files over to the computer and we'll talk to you back in the studio when we're going through it all on screen and we'll show you the next steps and let's start designing the flares and then get to 3D printing them. All right, back in the studio now. We're about to start the process of designing the flares. First things first, we've got to import the files from the scanner and bring it into the software that comes with the scanner so we can get it all set up on the computer. So this is the StarVision software from Einstar that works with the Einstar Vega scanner. This is where all the files from the scanner first come in. You can see all the files here in the model library. We've got a heap of data from the scan session that we just did. From here, I can then import them and start cleaning them all up, removing any unwanted bits, like parts that I don't require, like the wheels, tires, background, junk, and all that sort of stuff. To speed things up, I've already gone ahead and cleaned up all the models. You can see those here in the workspace. Here's a quick look at the front guard scan, but for now, we're just going to focus on the rear quarter flares. I also want to scan a front spoiler in, because that's going to all incorporate into the design of the front flares. So we'll do that in the future. So we won't worry about now. We'll just focus on the rear flares to start with. Here's the rear quarter scan. It starts out as a point cloud, as you see here when I zoom in. Then we can turn it into a mesh. You can also automatically align multiple scan layers together, which is super helpful. Once that's all done, I can export the files as an OBJ file, which is all ready to bring straight into Blender. So before we jump into Blender, a quick note on why I'm using it. If you're designing something highly technical, like a suspension arm or bracket, you definitely want to use a CAD program like SolidWorks or Fusion 360. Those are purpose-built for precision work like that. But freeform shapes like these, Blender gives me way more control. And personally, I'm just way more comfortable using Blender. To put things in a really simplistic way, CAD is kind of like using Lego blocks to build something where everything just snaps in place and just kind of aligns and works perfectly. whereas Blender's a bit more like sculpting. You can push and pull shapes around until you get exactly what you want. I'm sure you can also do similar things like that in a CAD program, but for now, with this one, I'm sticking with Blender. So we're now here in Blender. I've brought in all the scanned files and aligned them all properly. You can see I've also added in a tire model. That matches the planned tire size I'm running, which is 315/30/18. It just helps me visualize all the clearances and just kind of see how everything sits. Now, this is the original model of the flare that I designed, and I've been using in all my renders you would have seen. And now you can see how it sits over the top of the 3D scanned rear quarter. At first glance, it does look pretty close, but if I just printed this as is, the fit would be way off. But still, it's a super handy reference for me to work off to create the actual model. So let's get stuck into that now. I started off by creating a basic low poly quad mesh that kind of follows the shape of the original scan flare. It's kind of just enough detail for me to get the key lines and the silhouette. Now, I'm going to hide the scanned flare layer now, because from here, I'm mostly going to be using the original panel shape as a guide. For this part of the design process, I like to work in orthographic view. So basically, orthographic view flattens everything and keeps everything its like true sizes and scale. There's no perspective on it where when you look at something with your eyes, everything kind of goes to a vanishing point. So in orthographic mode, it's much easier to see where things line up, and it's of course much easier to actually design things to be exactly how you want them. You can kind of see here when I flick between the two, the grid behind the model changes to kind of, hopefully that explains what I'm trying to say. So if we just flick between them, you can see what I mean. If you remember back to when I was scanning, I mentioned that the flare was bowing inwards quite a bit. That's probably why I trimmed the old flare, because it was sitting way too close to the tire. And you can kind of see that here when I flick between the two layers. So hiding that flare layer now, I then reshaped my new flare design to better match the original wheel arch line. And I didn't just shift the inner edge, I also pulled the outer edge out to kind of keep the balance and maintain the overall shape and width. So once I had all the shape right, I then added a solidify modifier to give the part some thickness. Otherwise, Blender kind of just treats it as like a paper thin surface. Now I'm skipping over a lot of the small tweaks here because it took me a while to do. So I'm just going to jump to the finished part and show you how it looks. So here's the finished flare. I'll just isolate it so you can see the thickness and the overall shape. On the back side, I've added a lip that follows the surface of the panel underneath. The plan is to attach this using like high quality double-sided tape. Many of the modern OEM flares are mounted like this. But in saying that, I still might add a couple of bolts or studs just for extra security and to make sure it all aligns in the right spot. This first print's very much just a prototype, so we'll see how it all fits and we'll go from there. Now I've actually been playing around with a couple of other variations of the flare. First I'll show you option 2. This changes the top angle ever so slightly. This would give me a little bit more clearance on the top of the tire, which might be able to help me lower the car ever so slightly. Option 3 here, I've lowered the lip height to visually bring down the eyebrow line and make the car kind of look lower overall by tucking a little bit more tire. But first, I just want to print this original version and to test fit it on the car before I go too far with the others. Now to prep the file for printing. Blender has this handy little add-on called 3D Print Toolbox. That helps check for common issues for 3D printing, and it kind of makes sure everything's watertight and ready to go. Once that's all good to go, I export the 3D file and bring it into Bambu Studio, which is the slicing software that comes with my 3D printer, which is a Bambu Lab X1-Carbon. Now, one limitation with the printer that I've got is the build volume is 256 by 256 by 256 millimeters. And this part is obviously much bigger than that. So to help plan the cuts, what I do is in Blender, I created a few 250 millimeter cubes and I lay them over the flare to figure out the best slicing points. I don't actually slice anything
in Blender like this. I probably could, but I still prefer to do that in the Bambu Studio. But this just gives me a really good reference once I'm actually in the slicer. So in Bambu Studio, you can see the flare is way too big for the plate now I've imported it. So I'll quickly show you how I slice it up. So my first cut, based on what I just did before in Blender, is roughly straight through the middle here. Rather than just a dead straight cut, I actually had this little dovetail join, which kind of helps me clip it together, and it should give it a little bit of extra strength and just basically help me align it like a puzzle piece. I then repeat this process around the rest of the flare, guided by those cubes that we did just before in Blender. There's also a tiny little shaded zone just here in the slicer that does also help work out where the print plate boundary is, and it also just kind of helps arrange everything. So I'll skip ahead a little bit again. Now everything's all sliced up and arranged across a few build plates. In the program, you can do this quick little preview. It also automatically generates these support structures, which basically stop the parts from falling over mid-print. The slicer will also tell you how long the print's going to take, how much filament that it's going to use, and I'm not sure, there's a dollar figure here. I'm not sure that's in Australian dollars or US dollars, but regardless, it's a nice little handy estimate just to quickly look at either way. So with that all set up, it's time to hit print. For me, it's going to take a couple of days to organize all the prints. But for you guys, it should be super quick with a nice little montage. So let's get stuck into it and see how these prototype parts come out.
All right, so everything's now printed. As you can see here, I've got all the parts laid out in front of me. So next step that I'm going to do is I'm going to join them all together. So not only have we got their little dovetail joints here, but I'm going to also plastic weld them on the back. I've got my plastic welder here. I'm basically going to just stitch them together and just make a relatively solid part. When it comes to the real thing, we'll probably put some glue or something in between the joins as well. But for this initial prototype that I'm making, these little plastic welds should do the trick. So we'll put on a time lapse and watch it all come together. So there we have it. It is all now welded together, plastic welded together, I guess you call it, with those little staple things. So I guess next step now is to go just dummy fit it up to the car and see how it looks and see how the shape fits and see how the profiles work. And yeah, but otherwise I'm absolutely stoked with how good that looks. I don't know if you can see it in the footage, but it looks awesome. I reckon next step now is we go down, we check it out on the car, see how it all fits, see how all the shapes work, and go from there. Let's do it. Okay, so back down the shed here, and as you can see, I've already got it on the car. So after I assembled it together the other night, I couldn't help myself, and I came down here late at night, put some double-sided tape on the back and put it on the car just because I was so excited to see how it looks, and I didn't bring the camera. So doing it now, let's have a look. I'm so happy with how well it fits the car and the profile of the car. I guess I should know that because it's based off the 3D scan, but you're always a bit unsure. You just don't know. But it fits absolutely perfectly on this car. I took off the old wheel and I've just chucked the tire in underneath. I'll get some better footage walking around to show you it from all angles, but I am stoked. I'm so happy with how it looks. I'm not sure if I need to tweak much on the model. I wouldn't mind putting it on the actual hatch down with Dale just to see how it looks. Also see it with the cutout inner, because at the moment I've got this tire. It's basically resting on the original guard underneath. So it'd be interesting to see how much more clearance I have got going up and down. Ideally, this is pretty close. Where this tyre is sitting is probably pretty close to where I'd like the ride height to be. I don't actually know if that's possible. I don't know how much travel I need up and down in the suspension, how much it'll move in all the various directions, but I'm pretty happy with how this looks, ride height wise. So you can't quite see it in the footage. So the finish on this is not too bad. So, but as I've said all along, this is just a prototype. This is literally just for this purpose. See how it fits, see if I'm happy with the shapes. I'd like to get it, I'd like to stand back a bit further from the car. This car doesn't move, so it's on the hoist, it is what it is. If I can get it down on my hatch down with Dale, I can stand back from much further distance, get it more at normal ride height, and really appreciate how all the shapes and stuff go. But to be perfectly honest, I'm 99.9% happy with how this looks. I still wouldn't mind trialing some of those other ideas that I showed just before in the video, where I just maybe lower this eyebrow height ever so slightly. I think there might be some merit in that one. I'm not sure about the other one that I lifted this angle up through here. I don't know if that would work as well. But if I could visually lower it just ever so slightly to tuck a little bit more tire, I reckon that'd be pretty good, because the other height before, I had it down on the ground. I might flick a photo up of what I did just to show the height from the sill to the ground roughly. I wasn't too offended by that number. I think that's all for this episode. I hope you've enjoyed something a little bit different this time around. If you have liked this sort of stuff, let me know in the comments. I'm really interested to hear if this is the sort of thing that everyone, all the viewers out there that are watching, really enjoy this type of content, because I'm more than happy to do more of this. This is my wheelhouse, where I can talk about this really easily, and I can share as much information as I can. So if this is the sort of thing that you like, make sure you've hit like on the video, make sure you're subscribed, and also make sure you comment, say that you like it, ask me some questions about what you really liked about this video, and if you wanted to see more content like this, because I'd love to go into further depth when I do the rear spoiler, of course when I do the front flare, the front spoiler, everything really. If you're interested, I'll share it. If you're not interested and this video gets no views, well, maybe I'll just do that privately. Thanks again for joining us on this rebuild journey. Don't forget, go all in, build something incredible, and live your dream. See you in the next one.